In week 2 and week 3, we will talk about performance characteristics of instruments and data analysis. So, this will be covered in 2 weeks. So, we name it as performance characteristics of instruments and data analysis 1, which will be covered in week 2, and performance characteristics of instruments and data analysis part 2, which will be covered in week 3. So, what do you mean by performance characteristics? So, today's topic will be the performance characteristics. What are they? Actually, there are two types, static characteristics and dynamic characteristics. So, we will talk about what are the static characteristics, what are the dynamic characteristics, we will identify them, and we will talk about something called static calibration. Now, let us try to understand what do you mean by static characteristics of instruments. When you use an instrument to measure some process variables, you may ask yourself, how do you describe the quality of measurement? Or let us say you are measuring, say, temperature of some process using two different instruments, and let us say you are doing these things repeatedly. So, again, how will you compare the performance of one instrument against another? There should be some quantitative basis for this performance evaluation. So, when you say that, when you ask yourself that how to describe the quality of measurement, perhaps you think of whether the result is accurate enough, whether if I repeat the same measurement several times, whether there is repeatability or the agreement among the readings obtained in several trials. And how do you compare the performance of two instruments? This is what we just discussed, that if we have two different instruments which can be used for the measurement of some same process variable, how do I compare the performance of these two instruments? So, performance characteristics are quantitative basis for comparing the performance of an instrument with possible alternatives. Performance characteristics are quantitative basis for comparing the performance of an instrument with possible alternatives. There are two sets of performance characteristics, and both are used to evaluate the performance of instruments or to compare the performance of instruments. They are known as static characteristics and they are known as dynamic characteristics. Static means medium is stationary. So, the quantity you are measuring does not change with time. So, the medium is stationary, environment is stationary. And dynamic characteristics, the word dynamic means that the quantity I am going to measure is rapidly varying with time. So, there are two sets of characteristics, static characteristics intended for static environment, dynamic characteristics intended for dynamic environment. If a medium is varying very slowly with time, we can consider this to be static and can concentrate on static characteristics. Why do we classify these performance characteristics into these two categories, static characteristics and dynamic characteristics? Because of this reason, that the quantity being measured may remain constant with time or may vary very slowly. But there are applications where quantity being measured may vary very rapidly. So, it becomes natural to consider a set of characteristics for the medium which is remaining stationary or varying very slowly. But when the quantity being measured or the medium is changing very rapidly, it is natural to consider a set of characteristics which is separate from static characteristics. Accordingly, we classify them as static characteristics and dynamic characteristics. So, let us formally define static characteristics as follows. So, these are attributes associated with static measurement. So, static characteristics are set of criteria that are used to describe the quality of measurement when you measure a quantity that is constant or changes very slowly. It is important to note that it is the measured quantity that remains constant or changes very slowly. So, set of criteria, static characteristics are set of criteria that are used to describe the quality of measurement when you measure the quantity that is constant or changes very slowly with time. The quantity that we are measuring either remains constant or changes very slowly. So, under such condition or under static environment, the set of characteristics that we use to evaluate the quality of the measurement will be known as static characteristics. Similarly, dynamic characteristics is attributes associated with dynamic measurement. So, the formal definition will be the set of criteria that are used to describe the quality of measurement when we measure a quantity that is rapidly varying with time. So, again note this slide. The dynamic characteristics are set of characteristics which we must use to describe the quality of measurement when the quantity being measured is not stationary, the quantity being measured vary rapidly with time. So, this is under dynamic environment. So, static characteristics are set of characteristics which we will use to evaluate the performance of instrument under static environment. So, the quantity being measured does not change with time there, and dynamic characteristics are those characteristics which we must consider to judge the quality of measurement when the instrument is being used to measure a quantity which rapidly vary with time. So, under dynamic environment. So, the question we can ask now is, does static characteristics influence the quality of measurement under dynamic environment? The answer is yes. Static characteristics also influence the quality of measurement under dynamic environment. It is not that the static characteristics will not influence the quality of measurement under dynamic environment. We treat them separately. We treat static characteristics and dynamic characteristics separately, but the static characteristics will also influence the quality of measurement under dynamic environment. So, both the characteristics are important to evaluate the overall performance of an instrument, but for ease of analysis we treat them separately. Dynamic characteristics are easily described by differential equations, by set of differential equations. For linear instruments, that means for instruments which has a linear relationship between input and output, these differential equations will be linear differential equations. Oftentimes, they are ordinary linear differential equations for simple instruments or simple situations. Now, it is not very difficult to solve ordinary linear differential equations for a given input to get output. I am talking about mathematical analysis of an instrument. So, since dynamic characteristics can be analyzed by solution of ordinary linear differential equations, its analysis is not very difficult. But static characteristics are more nonlinear in nature and they also show up as statistical effect. Now, if I incorporate the static characteristics into dynamic characteristics, that means if I incorporate those nonlinearity that are present in static characteristics or statistical effects into the otherwise linear differential equations that represents dynamic characteristics, the overall system will be much more complex to handle. So, for simplicity, we treat static characteristics and dynamic characteristics separately. Then, instead of making a quantitative superposition, we can superimpose qualitatively the effect of static characteristics onto the dynamic characteristics. So, that will give me the overall picture. Now, let us talk about something called static calibration. The procedure used to establish the relation between the output and the input of an instrument if all the influencing parameters are controlled within working range. So, basically static calibration is the procedure used to establish the relation between the output and input of an instrument when all the influencing parameters are controlled within working range. So, by calibration we used to establish a functional relationship that exists between input and output, and this is done when all the influencing parameters can be controlled within the working range, and over this range this calibration will be valid. So, calibration is accomplished by applying known magnitudes of the input and observing the measurement systems or instruments output. So, we will introduce known magnitude of the input to the instrument. We will observe and record the instruments or measurement systems output, and from this known input out and the instruments output, we can establish the calibration or the functional relationship that exists between input and output. Static calibration refers to the input output relations obtained when only one input of the instrument is varied at a time, all other inputs being kept constant. So, let us define formally as follows. Static calibration refers to the input output relations obtained when only one input of the instrument is varied at a time and all other inputs are being kept constant. So, how do I establish this functional relationship, or how do I calibrate an instrument? How do I obtain the static calibration? So, let us talk about the steps for static calibration. First, for the given instrument, let us identify all the possible inputs. Let us identify all the possible inputs for the given instrument whose static calibration we want to establish. Next, decide which of the inputs will be significant for intended application. So, first identify all the possible inputs, then decide which of the inputs are more significant. Determine the apparatus and methods to control, that means vary or maintain constant, all significant inputs over the desired range. Since the static calibration will require the variation of one input while all other inputs are being kept constant, we have to identify and adopt method such that we can vary or keep constant these signifying inputs over a desired range. So, we have to identify the range and we have to adopt suitable methods so that we can vary or keep constant these significant inputs. By varying one input and holding the other inputs constant, establish the instrument's input output relations. So, now we vary one input and hold all other inputs constant and then establish the instrument's input and output relations. This input output relations can be an equation, it can be a graph which presents the relationship between input and output using a straight line or using a curve, we will see soon. So, there are different ways of expressing this calibration. It can either be in terms of graphs, it can also be in terms of equations. Oftentimes, there are simple graphs, there are equations also, and also sometimes they are presented in the form of a table. So, there are various ways of presenting calibration, but the purpose is same everywhere, to establish the functional relationship between input and output. Let us note that the calibration or this input output relation that you have obtained is valid only under the stated constant conditions of all the other inputs. So, the calibration should be used only under the stated constant conditions of all other inputs. So, there will be a range over which this calibration will be working. So, let us now look at few examples. You have done experiments or you have followed the steps that we just talked about to obtain the functional relationship between input and output for an instrument, let us say, and then these are the, let us say, the experimental points, and you see that you can draw a nice straight line through most of these experimental points, and this is the straight line that has been drawn. So, we say here that a linear relationship exists between input and output, and we also call the instrument as linear. So, if the functional relationship between input and output is linear, it has distinct advantages because this interpolation and extrapolation becomes extremely easy and reliable. Let us think of another instrument. These filled circles are experimental points, and you see that you cannot exactly draw a straight line between these input values and output values, but a slightly nonlinear curve is fitted. So, the instrument is nonlinear to some extent, but if I look at here, you see the instrument is kind of linear over this small range. So, in this range the instrument behaves like a linear instrument. So, over this range the relationship is linear, calibration is linear, but if I talk about this range, this instrument is not linear over the entire range. So, oftentimes we try to make use of those properties or principles which will give me a linear relationship between an input and output. In other words, the principles of measurements will be chosen such that I can obtain a linear instrument. That may not be possible always, but if it is done, you will get a linear instrument, you will get a linear calibration, and the interpolation and extrapolation will be much easier. If you look at here, so this is the relationship between input and output, which is extremely nonlinear in nature. So, this is a highly nonlinear instrument. So, extrapolation, interpolation is not very simple here compared to linear instruments. Similar to static calibration, we also have a dynamic calibration. When time dependent variables are to be measured, a dynamic calibration is performed in addition to the static calibration. A dynamic calibration determines the relationship between an input of known dynamic behavior and the instrument's output. So, a dynamic calibration determines the relationship between an input of known dynamic behavior and the instrument's output. Usually, dynamic calibrations involve introducing a sinusoidal signal or a step change as the known input signal and then recording the instrument's output with time. So, dynamic calibrations will require you to introduce either a sinusoidal input or a step change, and then we record the instrument's output with respect to time. So, there are both static calibration and dynamic calibration. We will stop here for this lecture 6 and we will continue for lecture 7 in the next class.